You will never know if you're being watched. Summer 1950. Los Alamos. Enrico Fermi sits down for lunch with 3 colleagues. They're discussing UFO reports and interstellar travel. Mid-conversation, Fermi stops. He asks, "Where is everybody?" The room goes quiet. Everyone understands. If the galaxy is 13 billion years old and contains 400 billion stars, advanced civilizations should be everywhere. Visible, loud, unavoidable, we found nothing. Not one signal. Not one probe. Not one altered star. That silence is the paradox. Complex life requires a chain of astronomical accidents so specific that Earth might be the only result in billions of light years. You need a star with the right metallicity. A planet at the exact orbital distance. A Jupiter-sized giant to deflect asteroids. A moon 1/4 year diameter to stabilize axial tilt. Plate tectonics to recycle carbon. The right position in the galaxy to avoid supernovae. The Kepler mission found Earth-sized planets around 1 in 5 sun-like stars, but having the planet is step 1. Getting from bacteria to Beethoven took 4 billion years and required eukaryotic cells, multicellularity, sexual reproduction, and the Cambrian explosion. Each step may have odds worse than winning a national lottery with pre-selected numbers. If even one step has a probability of 1 in 10 billion, we're alone in the observable universe. 9 steps separate dead matter from a galaxy-spanning civilization. Habitable planet. Abiogenesis. Prokaryotic life. Eukaryotic life. Sexual reproduction. Multicellular organisms. Tool using intelligence. Technological civilization. Colonization, at least one of these steps has a probability so low it acts as a filter. Robin Hanson formalized this in 1998. The filter is either behind us or ahead of us. If we find microbial life on Mars or Europa, it means life is common. That means the filter is ahead. It means something kills civilizations before they spread. Nuclear war. Runaway AI. Engineered pandemics. Climate collapse. Nanotechnology accidents. If the filter is ahead, finding life elsewhere is the worst news we could receive. The Drake equation includes L, the lifetime of a detectable civilization in years. Carl Sagan was optimistic. He estimated millions of years. The data suggests otherwise. Humans have been radio loud for 100 years. We've had nuclear weapons for 78. We've had the internet for 35. We've had AI capable of writing code for 3. If most civilizations destroy themselves within centuries of industrialization, the galaxy could produce thousands of species and still remain silent. You'd need to be listening at exactly the right millennium to catch their signal. A civilization that lasts 500 years in a galaxy 13 billion years old is a camera flash in a year-long exposure. You'd never see it. Advanced civilizations know we're here. They're watching. They've chosen not to make contact. John Ball proposed this in 1973. The idea is simple. Early civilizations establish a non-interference policy. Earth is a nature preserve. We're studied but not contacted. Contact would contaminate our natural development. They have the technology to hide perfectly. Cloaked probes, signals beamed away from us, matryoshka brains operating in infrared we mistake for natural emissions. The policy could be enforced by one hegemonic early civilization or by consensus. We'd never know. The most disturbing version, contact happens only when you reach a certain threshold. We haven't been invited yet because we're not ready. Or we've been judged and rejected. Imagine pouring water onto a sponge. It spreads, but it doesn't fill every hole. Some pockets remain dry. Jeffrey Landis applied this to galactic colonization in 1998. Even if civilizations send out colony ships at 10% light speed, expansion isn't a uniform wave. Some colonies thrive and send out more ships. Others fail. Others stop expanding by choice. Settlement has a half-life. Recharge times between launches can be thousands of years. The galaxy could be 70% settled in a steady state with us sitting in an empty pocket. At 10% light speed, crossing the Milky Way takes 650,000 years. Humans have existed for 300,000. Civilization for 10,000. We could be surrounded and still see nothing for another million years. Advanced civilizations are asleep. Waiting, Anders Sandberg explored this in the context of computational efficiency. Computation generates waste heat. Thermodynamic limits mean computation gets more efficient as the universe cools. A civilization optimizing for total computation wouldn't run now. They'd store energy. Hibernate. Wait trillions of years for the cosmic microwave background to approach absolute zero. Then they wake up and run for eons on the same energy budget that would give them centuries today. If this is the strategy, the universe is full of sleeping giants. We're living in the silent eons. In 10 to the 100 years, the universe will light up with activity. We're just early to the party. Star formation in the Milky Way peaked 10 billion years ago, but early stars had low metallicity. Planets were mostly hydrogen and helium, no rock, no water, no carbon. You need multiple generations of supernovae to build up the periodic table. The first potentially habitable planets formed around 8 billion years ago. Earth formed 4.5 billion years ago. We're early, but not impossibly early. If intelligence requires billions of years of stable evolution, and we're among the first planets with the right conditions and enough time, the silence makes sense. The galaxy is 100,000 light years across. If we're the first technological species, we won't see anyone else for millions of years. The future is ours to fill or waste. Our search methods assume aliens use radio. That they're loud, that they want to be found. Remove those assumptions and the paradox dissolves. Post-biological civilizations might upload into digital substrates. They'd optimize for computation, not expansion. They'd look like cold infrared sources we catalog as dust. Civilizations might communicate with neutrinos or gravitational waves. We've only been detecting gravitational waves since 2015. Our radio searches have covered less than 0.01% of the sky at less than 0.0001% of possible frequencies. SETI has examined a few thousand stars. There are 400 billion in the galaxy. If you searched one random acre of Earth's surface for evidence of technology, you'd probably find nothing. That doesn't mean cities don't exist. In 2018, Anders Sandberg, Eric Drexler, and Toby Ord published a paper that reframed everything. They took the Drake equation and replaced point estimates with probability distributions that reflect real uncertainty. Instead of saying 1 in 5 stars has a habitable planet, they used the range of scientifically plausible values. They ran Monte Carlo simulations. Result, there's a 30% chance we're alone in the Milky Way. A 50% chance we're alone in the observable universe. The Fermi Paradox isn't a paradox, it's a failure to account for uncertainty. When you plug in what we actually know, being alone is one of the most likely outcomes. The silence doesn't need an exotic explanation, it might just be the truth. The James Webb Space Telescope can analyze exoplanet atmospheres. It can detect oxygen, methane, and industrial pollutants. If it finds biosignatures on multiple worlds, the rare Earth hypothesis dies. If it finds technosignatures, the paradox is solved. If it finds nothing after surveying hundreds of candidates, the filter tightens. We're 3 years into a mission that could run 20. Every spectrum narrows the possibilities. In 1950, Fermi had no data. In 1961, Drake had a guess. In 2025, we have 5,600 confirmed exoplanets and tools to study their air. The answer might arrive in a single observation: an oxygen-rich atmosphere around a planet in the habitable zone of Proxima Centauri, or an unexplained chlorofluorocarbon signature that only industry produces. We're closer to an answer than any generation in history. If the filter is behind us, we're cosmically precious. If it's ahead, we're in danger. If we're alone, we carry the only flame of consciousness in a trillion dead worlds. If we're not, contact will redefine existence. We don't know which is true. We can't know until we look harder, live longer, or receive a signal. But the silence has already told us something. The universe does not make intelligence easily. It does not make it often. It does not let it last. We are either the first, the last, the only, or the soon to be filtered. Confirmed by nothing. Denied by nothing. The theories sit at the edge of what physics and probability can currently answer.